In recent months, the world of artificial intelligence has witnessed an event that many analysts are already calling one of the most alarming and at the same time, one of the most important in the entire history of modern neural networks. Anthropic, a company that for a long time was considered the most cautious and responsible among all major AI developers, unexpectedly issued a warning that has unsettled not only Silicon Valley investors, but also the governments of the world's largest nations. The organization that created the Claude family of models has effectively acknowledged that the development of artificial intelligence is beginning to approach a new phase whose consequences nobody is yet capable of fully calculating. The discussion centers on a concept that only a few years ago was considered pure science fiction. Today, however, it is being discussed not by futurist writers, but by leading engineers in the world's largest AI laboratories. This concept is known as recursive self-improvement of artificial intelligence. Put as simply as possible, it refers to the moment when artificial intelligence begins participating in the creation of the next generation of artificial intelligence. This idea lies at the heart of Anthropic's latest research, and it is precisely what prompted the company's unexpected statement about the need to consider slowing the global AI race. For many people, such warnings may sound strange. After all, companies like Anthropic, OpenAI, Google DeepMind, and xAI have spent years convincing the world of the extraordinary benefits of artificial intelligence. They spoke about future breakthroughs in medicine, cures for previously incurable diseases, new sources of energy, advances in materials science, robotic assistance, and dozens of other technologies expected to transform civilization. Yet today, these same people are beginning to talk about risks, and they are no longer discussing standard concerns such as fake images or job displacement. The conversation has now shifted toward the possibility that the pace of development could move far beyond humanity's ability to control the process. Particular attention was drawn to statistics that Anthropic itself revealed in its materials. According to the company, Claude already writes the majority of the code used internally at Anthropic. Just a few years ago, such a figure would have sounded like fantasy. Engineers wrote every line of software manually. Today, the situation is changing before our eyes. Increasingly, humans define the task, while the neural network independently proposes the solution. More and more often, engineers are no longer writing code, but reviewing code written by machines. The human role is increasingly beginning to resemble that of an auditor rather than a creator. This is where the first cause for concern emerges. Imagine a laboratory of the future. Hundreds of talented engineers are working on the next generation of artificial intelligence. Yet a significant portion of their tasks is already being performed by artificial intelligence itself. It analyzes errors in the previous version. It proposes new architectural solutions. It optimizes software code. It assists with research. It accelerates model training. It creates tools for building even more powerful models. At first glance, this may appear to be ordinary automation. However, if one looks deeper, a completely different question arises. What happens if each new version of artificial intelligence helps create the next version faster than the previous one helped create it? This is precisely the scenario that many researchers describe as the beginning of a technological avalanche. Every new step accelerates the next. Every new generation of AI increases the speed at which the following generation appears. At first, development takes years, then months, then weeks, then days, and at some point, humanity may find itself facing a process unfolding faster than even the world's best specialists can fully understand. What is especially interesting is that these concerns are not being voiced by outside critics of technology, but by the very people developing these systems themselves. Anthropic is not an opponent of artificial intelligence. On the contrary, it is one of the most advanced AI laboratories on the planet. That is precisely why its warning sounds so serious. When a company that builds some of the world's most powerful models begins talking about the need to prepare for a scenario of recursive self-improvement, many people interpret it as a warning signal. Against the backdrop of these statements, a new wave of discussion is spreading throughout the industry. Some experts believe that Anthropic is simply trying to prepare the public in advance for another major leap in Claude's capabilities. Others are convinced that the company is genuinely observing processes that are proving unexpected even for its own engineers. Still others believe that this marks the beginning of the largest technological race in human history, where the prize is not merely market leadership, but control over the future of the global economy. However, the most troubling aspect of this story is not that Claude is already helping write software code, nor even that modern models are beginning to perform increasingly complex engineering tasks. The real concern lies in the speed of the changes taking place. Looking back just a few years, it becomes obvious how rapidly the industry is evolving. Not long ago, language models struggled with basic logic, made a huge number of mistakes, and could not maintain long chains of reasoning. Today, those same systems are capable of analyzing scientific papers, designing software, assisting in biological research, writing complex algorithms, and solving problems that previously required highly qualified specialists. Many engineers admit that the results produced by modern models sometimes make them feel less like developers and more like observers, watching a process that is advancing far faster than expected. These discussions intensified especially after the arrival of newer generations of Claude. Each new version demonstrated improvements across virtually every area simultaneously. Memory improved, the ability to work with large volumes of information improved, reasoning capabilities improved, answer accuracy increased, and the capacity to perform multi-step tasks expanded. Many experts began noticing an interesting pattern. Whereas previous generations of AI typically delivered improvements of 10% or 20%, some capabilities are now growing in sudden leaps. Sometimes a new model demonstrates abilities that developers did not expect to see at this stage of the technology's evolution. Such phenomena have long been known in the industry as emergent abilities. These are situations in which a model begins displaying skills that nobody explicitly programmed. No one wrote a dedicated module for that function. No one created a separate algorithm for that behavior. Yet after reaching a certain scale, the neural network suddenly begins exhibiting an entirely new level of capability. It is precisely this effect that causes many researchers to approach further AI development with caution. Within the world's largest laboratories, a question that only recently sounded like the plot of a science fiction movie is being discussed more and more frequently. What happens if one of these models reaches a level at which it can independently discover ways to improve its own efficiency faster than humans can? So far, that has not happened, but the very possibility of such a scenario no longer seems unbelievable. When Anthropic publishes research on recursive self-improvement, it is referring precisely to this potential turning point. Interestingly, many analysts compare the current situation to the early days of the internet. In the early 1990s, only a small group of specialists understood the scale of the transformation that was approaching. Most people viewed the internet as an interesting technological novelty. A few decades later, the internet had completely transformed the global economy, politics, education, commerce, and the daily lives of billions of people. Today, many believe that artificial intelligence could become an even more transformative technology. If the internet changed the way information is exchanged, AI could change the very process of creating knowledge. Against this backdrop, an unprecedented race is unfolding among the world's largest companies. Anthropic, OpenAI, Google DeepMind, xAI, Meta, and major Chinese corporations are investing tens of billions of dollars in computing power. New data centers are being built around the globe. Chip manufacturers can barely keep up with demand. Thousands of engineers are working on new architectures. Every company understands that the winner of this race could gain an advantage that competitors may be unable to catch up with for years. This is where the central dilemma of our time emerges. On one hand, nobody wants to fall behind. If one company decides to slow down, its competitors will continue moving forward. If one country introduces restrictions, other nations may refuse to follow those rules. On the other hand, the faster the technology develops, the less time remains to understand its long-term consequences. Anthropic is effectively pointing to exactly this problem. The company acknowledges that stopping the global race is extraordinarily difficult. while simultaneously warning that a lack of coordination could lead to situations for which humanity is unprepared. Many experts draw parallels with the nuclear era. After the creation of the first atomic bombs, the world's major powers were forced to develop international control mechanisms. The reason was simple: the consequences of mistakes could be catastrophic for the entire planet. In the case of artificial intelligence, the situation is different, but the logic remains similar. If a technology becomes so powerful that it begins influencing the global balance of power, its development gradually ceases to be merely a technical issue and becomes a matter of international security. Some experts go even further. They believe that the next 10 years could become the most important period in human history. In their view, the foundation of future civilization is being laid right now. If modern models continue improving at their current pace, by the end of the decade, the world could be dealing with systems that surpass the best human experts across many intellectual fields simultaneously. This goes far beyond programming. It includes science, engineering, economics, medicine, data analysis, and strategic planning. For the average person, such predictions may sound abstract. However, the consequences could be very concrete. Imagine an artificial intelligence capable of completing in a few hours a volume of research work that previously required months. Imagine a system that can analyze millions of scientific publications and identify patterns invisible to human observers. Imagine a model that helps design new materials, new medicines, and new energy technologies. All of this is already beginning to emerge in its early stages. That is precisely why Anthropic's statements triggered such a strong reaction. The company is effectively telling the world the following: progress is advancing faster than many anticipated. The capabilities of these systems are growing more rapidly than expected. And if this trend continues, humanity may be approaching an era in which artificial intelligence becomes one of the primary forces shaping the future of civilization. The most remarkable aspect is that no one today can accurately predict where the limits of these capabilities lie. Some researchers believe we are still only at the very beginning of the journey. They compare modern models to the first computers of the mid-20th century. Yes, they are impressive compared with previous generations of technology, but compared with what may emerge in 10 or 20 years, they could eventually appear primitive. If this perspective proves correct, today's discussions surrounding Claude, GPT, Gemini, and other systems may one day be remembered as the opening chapters of a much larger story. That is why more and more engineers are beginning to ask, not whether artificial intelligence will change the world, but how quickly it will happen. And judging by Anthropic's warnings, the answer may be far more surprising than most people are prepared to imagine today. For the first time in the history of the digital age, the creators of advanced AI systems themselves are openly saying that the speed of progress is becoming a risk factor in its own right. And if even the developers at the center of this revolution are sounding the alarm, then perhaps the world really is approaching a threshold beyond which familiar assumptions about technology, work, economics, and even human intelligence may never be the same again. But the deeper analysts dig into the possible consequences of this new era, the more often one deeply uncomfortable question arises. What happens if one of the leading laboratories truly becomes the first to approach the creation of a system capable of accelerating its own development faster than its creators can understand what is happening? This is precisely the question being discussed more and more frequently behind the closed doors of the world's largest technology companies. And although industry representatives publicly choose their words carefully, outside official interviews, many specialists admit that the pace of development in recent years has surpassed even the boldest forecasts made at the beginning of the decade. Imagine a situation in which the next generation of Claude gains access to enormous amounts of engineering data, scientific research, and the results of its own previous experiments. Every day, the system analyzes millions of lines of code, millions of documents, and thousands of new scientific papers. It identifies patterns that humans overlook. It proposes optimizations that nobody had considered. It helps create tools that make training new models faster. As a result, each development cycle becomes faster than the one before it. If creating a new generation of AI initially took 2 years, then 1 year, then 6 months, humanity may eventually face a situation where the speed of progress begins to resemble a snowball rolling downhill. This is why many experts believe that the true revolution of artificial intelligence may not lie in individual features, such as text or image generation. The real revolution lies in accelerating scientific and technological progress itself. For thousands of years, the primary limitation of civilization has been human intelligence. Every discovery required time. Every research project required specialists. Every new technology went through years of experimentation and mistakes. But if a tool emerges that can multiply the speed of research across virtually all fields simultaneously, the consequences could be enormous. Some economists already call artificial intelligence a new industrial revolution. Others, however, consider that comparison far too modest. In their view, we are witnessing something far larger. Steam engines amplified human physical labor. Computers amplified humanity's ability to process information. Artificial intelligence is the first technology that begins to amplify the process of thinking itself. This is why so many predictions are becoming increasingly radical. For example, in pharmaceuticals, AI is already helping identify promising molecules for new medicines. In materials science, neural networks participate in the search for new compounds for batteries, solar panels, and superconductors. In software development, models help create complex systems in a matter of hours. In engineering, they can analyze thousands of design variations and select the most efficient solutions. For now, these appear to be individual achievements, but when viewed together, a very different picture emerges. It begins to feel as though humanity is creating a tool capable of accelerating nearly every scientific discipline at the same time. Against this backdrop, it becomes easier to understand why Anthropic decided to publicly raise the topic of recursive self-improvement. The company is not claiming that such a moment has already arrived. However, its researchers warn that signs pointing towards such a scenario are becoming increasingly visible. And if such a tipping point truly exists, preparations must begin before the changes start occurring, not after they are already underway. Interestingly, many engineers within the industry are increasingly using the term intellectual infrastructure. They are referring to a future in which AI becomes as fundamental to the economy as electricity or the internet. Most people do not think about power plants every day. They simply turn on the lights. In the same way, billions of people may be using AI every day within a few years without even realizing it. It will help doctors make diagnoses, engineers design buildings, teachers create educational programs, companies manage logistics, and governments analyze vast amounts of data. However, the more important this technology becomes, the higher the cost of potential mistakes. This is why many experts believe that the coming years will become a period of unprecedented tension between speed and safety. Some will demand accelerated development, arguing that humanity cannot afford to slow down scientific progress. Others will insist on a more cautious approach, warning about the risks of systems whose capabilities may not be sufficiently understood. A special role in this story is played by the factor of competition between states. The United States clearly understands that leadership in artificial intelligence is becoming a matter of national security. China holds a similar position. Massive investments are being directed into computing power, chip production, scientific research, and training specialists. Each side fears falling behind. And it is precisely this competition that makes the idea of global slowdown extremely difficult to implement. In effect, the world has found itself in a situation reminiscent of the early space race of the last century. Back then, superpowers competed to reach space. Today, they are competing to create the most powerful intelligent systems in human history. The difference is that the consequences of the current race may be far greater in scale. If space technologies changed humanity's perception of the universe, artificial intelligence may change humanity's perception of intelligence itself. Some futurists even suggest that future historians will divide eras into the period before advanced AI and the period after it, just as we now distinguish between pre-industrial and industrial epochs. Perhaps humanity is now standing on the edge of such a transition. Most people continue living ordinary lives, going to work, watching the news, and making plans for the future. But somewhere inside data centers filled with tens of thousands of accelerators, systems are already running that are becoming more powerful with every training cycle. This is why Anthropic's recent statements have caused such a strong reaction. They did not sound like a marketing campaign for a new model. They sounded like a warning from the people closest to what is actually happening. And when engineers building the most advanced systems on the planet begin speaking about the need to prepare in advance for possible AI acceleration, even the most convinced optimists are forced to pay attention. Perhaps in a few years these concerns will seem exaggerated. Perhaps humanity will successfully adapt to new technologies just as it adapted to the internet and computers. But another possibility also exists. It may be that right now, the most important technological transition in the history of civilization is beginning. A transition that will define economics, science, security, and the balance of power for decades to come. If that is truly the case, then today's discussions around Claude, Anthropic, and recursive self-improvement may turn out to be only the first signs of far more significant events that are only just beginning to unfold before our eyes.